Hello, um, this is Nicholas, and I'll be taking you through the AgriPredict web app alongside my colleague, Mr. Junior. Uh, this is a post-harvest loss prediction app, and this is the problem statement we have for our app. Post-harvest losses are a major problem affecting food security and farmer income. Farmers lack early predictions and well as the mitigation strategies. So what you have decided to come up with is one that can predict potential losses before they can happen to minimize the wastage. Then the solution you have is AgriPredict. This is our app, web app. It predicts the losses, loss categories, low, medium, and high. Provides smart mitigation advice based on predictions, as well as supports both single inputs and bulk CSV file uploads. As I'm going to be taking you through the slides and so a brief overview about our web app. It accepts input from the users by interacting with the sliders shown on the user interface, where they can change the levels of the temperature, humidity, and rainfall, as well as other features. Those are the input features that can affect the level of post-harvest losses. Then after that, the user can tap the predict button to view the predictions and receive prediction success message and a graph that shows the confidence scores of the prediction. In this app, we have notification messages after every step. So the second option for data input is where the user is required to input a CSV file and the app shows a preview of the details in the uploaded dataset. Then now our app walkthrough input section. That's where you have the sliders for temperature, humidity, rainfall, and other features that were put for future works. So the user can make adjustments on those sliders. Then the single prediction on one click prediction with confidence scores, you get the results as well as the visualization, the bar chart of the confidence levels, and the batch prediction CSV file upload option of not maximum capacity of 200 MBs. So these are the default input features I've been telling you about with that was temperature with the sliders so that you can adjust your inputs accordingly. That's for the default display. You can make the predictions from there. Then the notifications, we have the predict successful after doing the data prediction via input features, as well as the successful batch prediction after uploading a CSV file. So my colleague, Mr. Junior, is going to take you from there.
Thank you, Nicholas, for that part of the presentation. I shall continue with the second part where I talk about the prediction example. By default, our application will come with an example data for prediction, which can be adjusted via sliders, as Nicholas said. So by default, our app comes with data like temperature, gives some certain temperature in degrees Celsius, then humidity at some percentage, then rainfall gives you some value. It's a random value in millimeters, then other features, then it has the output, which is predicted according to the input features. For example, based on this input we had, predicted that the loss is high and the mitigation advice was to improve drainage, use the temperature control, and store using preservations. After that, uh, we have the visualization, the actual visualization of the prediction and the mitigate advice. Um, the prediction is shown in form of a graph of confidence scores, and the mitigation advice is written in form of certain sentence like enhance storage, use preservations, and control temperature, or improve drainage if rainfall is high. So that's the default visualization and prediction that comes when you open the app and you want to interact with it. So after that, after the default predictions or the default data inputs, the app allows you to upload your own data in form of a CSV dataset file. So the interface has the button where you can tap to browse and select the CSV file. And when you upload it, it shows you that the dataset has been uploaded and you get a preview of your dataset. So this is an example of a preview of the data in the uploaded dataset. And this preview can be downloaded, and still you can search for specific data from this preview, and you can go on after previewing the data to predict the post-harvest losses. So after previewing the data, there's a button that requests you to predict. When you tap it, the prediction of the post-harvest losses has to appear in form of a table showing the input features in the uploaded data sets, and then with corresponding post-harvest losses. Then after that, we can talk about the stack or what we use to build the application. We have this front end part, and then we have the back end, and then we have the model we deployed. We have the libraries we used and the architecture. So when talk about the stack, the front end part was built using Streamlit, which is a front end UI developing framework for Python. Doesn't require the JavaScript and CSS codes to build the UI. It builds the UI itself without the need of those web tools. So the back-end model is a PyTorch neural network, which was used to build the post-harvest loss predicting model. Then deployment, the app was deployed on Render, and for our benefit, it was deployed freely. So it's hosted on some servers where it can be accessed anytime. Then the library is used. We used some libraries for the model where we used NumPy, pandas for data processing, then joblib for model and scalar loading, then matplotlib and seaborn for data visualization and plotting of graphs. Then we have the architecture of our application, where we have the user interfaces built by Streamlit, as I told you. Then the model and scalar served as the PKL files and joblib files. Then the prediction engine, which is the PyTorch model inference. Then the deployment server. That's it. That's what we had for now. Thank you for watching.